For number 5, we're asked to find out where the graph has increasing intervals, decreasing intervals, and at what point we would have a relative max or a relative minimum. So the first thing we're going to do is we're going to look for the first derivative. And we're going to use the chain rule. So we're going to bring 1/3 out to the front. We're going to write the inside function as is, reduce the power by 1, and then we're going to multiply by the derivative of the inside function, which is -1. Okay, so here we use the chain rule. Remember, we use the chain rule when we have a group of terms, all of that raised to the same power. We're going to clean this up a little bit since we're going to set this equal to 0. I'm going to write this as -1 at the top of the fraction, and then I'm going to bring the 1 minus x to the -2/3 power. I'm going to bring that to the bottom of the fraction to join the 3 so that that's written with a positive exponent. Alright, so there's our first derivative. And we're looking for two things: where the first derivative might be 0 or where the first derivative might be undefined. Okay, so let's look at potentially where our first derivative might equal 0. So we're going to set that equal to 0. Think about that as a fraction by putting it over 1. And we're going to say 0 times the denominator will give us 0, minus 1 times 1 will give us -1. And we're left with the false statement, which says that whatever we were looking for, there are none. So there are no x values that have a horizontal tangent line. So we're going to look at what maybe would make our first derivative become undefined. So you can set your denominator equal to 0. If I divide both sides by 3 to get rid of the 3, I'm left with 1 minus x to the 2/3 power equals 0. Now keep in mind that what we're saying is basically what would I need to raise, so here's my base, what would I need to raise to any power to get 0, and the only way that that can happen is if the base was itself 0. And the only way that the base of that exponent could be 0 is if we add x to both sides, we get 1 equals x. So this is the only significant point that we find that will separate our number line into parts. So we have x equals 1. Okay, we're going to evaluate the first derivative to the left and to the right. So we're going to pick some test values. I'm going to pick, to the left of 1, I'm going to pick 0. And I'm going to plug that into the first derivative. And I'm going to plug it into this form of that first derivative. Okay. So we get -1 over 3 times 1 minus 1 is 1. Or sorry, 1 minus 0 is 1. So that gives me 1 to the 2/3 power. 1 to any power is always 1. So we end up with -1 over 3. And since this is a negative slope, we know that the function is decreasing from left to right on the left side of 1. To the right of 1, I'm going to choose 2. I'm going to plug that also into the first derivative. Get -1 on top, and that's 3 times, and this is -1. 1 minus 2 is -1. And we're going to raise that to the 2/3 power. And remember what the 2/3 power means is that we're going to take the cube root of it, and then we're going to square it. After I take the cube root of -1, we get -1, and then anything that I square, I'm going to get something positive. So on the top of the fraction, -1, at the bottom of the fraction, we will end up with something positive because of the fact that we are going to square whatever value is inside the parentheses. So this turns out to also be a negative slope. So that means you're also decreasing to the right of 1. So we're decreasing, and then we continue to decrease to the right of 1. So where are we increasing? Well, we're increasing nowhere, so there are no intervals for which we are increasing. Where are we decreasing? So once again, there's two ways that I will accept for this answer. You could say -infinity all the way to 1, and then from 1 to infinity, Or if you recognize that x equals 1 is included in the domain, make sure there's not an asymptote there, then you could put them together into one interval from negative infinity to infinity. Either solution I will accept as correct on the exam. Do we have a relative max or a relative minimum? So for this particular graph, we did not switch from increasing to decreasing or vice versa. So in this case, since we do not switch, then there is no relative max and there is no relative min.